She is not your host, but I am. There we are. Okay. We are reviewing our ionic compounds. Now, these are different. To repeat, the molecule naming system that we use is for non-metals. Two non-metals come together is where we use that system. Ionic compounds tend to be, well, they have to be cations. You guys familiar with the word cations? Yes? No? You've heard it. I don't think you've memorized. Anions are negative. Cations are positive. Most often, the cations are going to be metals. There's an exception that you see a lot with hydrogens are positive quite often, most often. Sometimes it's negative. Most cations are from the left side of the step. Iron, zinc, etc. Anions are negative. They're non-metals. Okay. Then we know that there's polyatomics, many atoms to make one. We'll review. Okay. If you want a word association, because I'll say anion and cation, N, negative, anion, negative ion. Okay. I don't know. We're going to take a look at this chart. And you need your periodic table and ion sheet. That's where you're going to find this. Just have it out separate. You're going to use a tool. Flip it over if you're not on the table of ions. I know so. The top says table of ions. Periodic table of ions. Good. Here's what we're going to do. We're going to do a few reviews, and then I'm going to give you guys a chance to try some to review. Now, first of all, lead 2 and lead 4, I'm going to kind of do them both at the same time, because I'm doing this on purpose. To remind you, some of the metals have multivalent, but it doesn't matter. They have multiple possible charges. So in the name, I have to tell you which one it is. Lead 2, I don't think it's a surprise. It's the one with the charge of 2 plus. Lead 4 is the one with the charge of 4 plus. To review, usually, well, not usually. The first thing is the cation, the positive. So we'll usually start with a metal. So lead 2, you look it up on the sheet. Lead is, now this isn't, but it's right here. And you'll see it there. It's possibilities of 2 or 4, but you need it for the symbol. So you might have to scan if you don't remember that. It's like, what? It isn't an L? That's because English isn't the only language in the world. Plumbian is actually the Latin word for plumbers. They used to use lead a lot. So PB, I'm going to just a second. We write down the ions. PB plus oxygen, oxide. We look it up if you don't know it. You'll become familiar with a lot of them. It's 2 negative. By the way, most books, and I tend to write down 2 with the minus sign behind it. You do it like this, negative 2 in front, I don't care. It means the same thing. That's sort of a math word. You'll see me do it that way. I'm not too sticky on that. Now, we have to come up with the formula. I'm going to review, and some of you can see. So this is a thinking page. You don't have to write this down. PB, 2 plus, O, 2 minus. So I'm thinking here, this represents 2 positive charges, right? This represents 2 negatives. And do they fit together? By going. So, what I mean by do they fit together? Do they add up to 0, right? If the charges match, you just put them side by side, PBO, right? The whole point is, this is a review, so I'm not going to go on. So, the formula you write down. This represents that a unit of lead oxide has 1 lead, 1 oxygen. This is going to be important. Balancing, and then later on when you learn stuff out, right? I know you've done this. You need a refresher. So lead 4, I already know this. PB, and it tells you the charge. I've got 4. I'm going to write down what I'm doing. Do these add up to 0? Heck no, right? What do you need more of? Obviously, the oxygen. I need a second one to think this through. Does this add up to 0? You can see they level up. You have as many positives as negatives. Now, you're not going to use diagrams to do this, but I want you to understand what this represents. That's the deal. Is that helping you? I don't know. Anyway, so we say 1 to 2 ratio. Right? Now, I'm using this one because did you guys ever think of crisscrossing? When I say that, I'm talking about take the charge of 1, take the charge of 5. But then this is like fractions. If you do that, it's a P2O4, and that's not in the lowest, like the common denominator, or on the lowest common multiple and stuff. You see, probably this one's easy enough, and usually 4 to 2 is how people can run this happens. You can reduce the ratio. So I need 1 lead, 2 oxygen. So, lead. I'm assuming this is rhodium. Is this correct? There's abundance. I know you've had 3 different teachers. I'm not saying you will memorize or know everything. I'm asking you, everybody's seen. Right? Yeah. Zinc and nitrate. Now, zinc, easy enough to find, and it's not zinc with a Roman numeral behind it. So you've got to look it up if you don't know this. You probably don't. And the charge is nitrate. You can look and look and look on the element part of that table. You're not going to find it. It happens to be in the center of your ion charge. Find nitrate for me. It's a collection. It's a polyatomic ion. And the important part is negative. NO3. 1 negative charge. So the math is pretty simple, but I'm still going to show you the diagram. This is a good crisscross. I'm going to need 1 zinc to 2 nitrate. What does that represent? I'm going to leave this. I'll need it. 1 zinc. 1 nitrate to start. See what we already know the answer. We kind of talked about it. Here's a nitrate. Here's a zinc. Oh, that's not a nitrate. Oh. Charge of -1. You can see right away that's not going to work, right? This is where I said if you do this crisscrossing, the lowest term right off the bat, which is 1 to 2 ratio. Let's just see here, though. I need a second negative to add to 0, don't I? That does work. This represents the formula. 1 zinc needs 2 groups of NO3. You guys remember what you did when you had something like a polyatomic ion, though? You can't just put. I'll show you the wrong one. I don't like showing mistakes. But if I do this, let's say 2. This is confusing. What's 2? What do I need to add in? Recall? Yep. Yeah, a bracket 6. There's 2 groups of this big thing. 2 groups of NO3. Formula. By the way, I'm being careful. I'm not saying molecules. These aren't molecules. Ionic compounds. They don't come as little units like water. There's a H2O. If you had a you don't have a microscope, you can see water more. But if you did, imagine, you would see little H2Os bouncing around, or ammonias. You'd see little ammonia NH3 groups stuff bouncing around. You will not find zinc nitrate or lead oxide, etc., lead 2 oxide, in little units. This is just the ratio overall. So I'm careful not to use the word molecule. If you did, I'd know what you mean, but try to use the right. Ammonium sulfate. I'm going to switch colors only because my spacing here. So ammonium is the only polyatomic cation, positive ion, that you'll come across in my class. So the rest are going to be elements. So ammonium, you look at the top. What is ammonium? Like ammonia. The top. Or with a positive charge. Great. Sulfate is also from the top. Tell me about that one. Sulfate? No. Now, you probably noticed that I bolded on that chart the ones we use most often. Nitrate, sulfate, etc. The ones we use. Okay. The other ones you might come across. Okay. Crisscrossing, I can see it's a 2-to-1 ratio. But do I need to do the diagram for this? I don't think so. It's a 2-to-1. Similar diagram together. So I'm going to go with NH4. I need 2 of them. And then the sulfate, I only need 1. I don't need to put it in brackets. It's actually incorrect to put it. I just need 1, and I just write 1 down. That represents 2 groups of N, 2 groups of H4. So really there's 2 N's, 8 H. There's 2 groups of H. 1 S, so 4 oxygen. Now, working backwards, the names. Ask that we work backwards in the same way. In the sense that we're going to list the ions. So I have to kind of uncrisscross. There's one strategy. Fe2O3. If I uncrisscross, does this give me valid charge? Well, if I move, when I say uncrisscross, I'm saying the 3 goes up there, the 2 goes up there. Right? Let's see if that works. Fe 3 plus O with 2 minus. You probably have the oxygen memorized. Those are valid charges. We're going to stick with them. But iron is one of the ones where you have more than one possibility. Look on the chart. Iron 2 and iron 13. So my name, I have to know what is it? Roman numeral 3. Iron 3. The second thing, you always drop the ending to have IE oxide. And that is for the anions that are single element. The anions that are at the top, like sulfate and nitrate, you use the ending exactly as it is. Actually, your ion chart tells you exactly what oxide. Now, this uncrisscrossing strategy doesn't work here. This is 1 oxygen to 1 iron. And I know that iron can't be 1, and I know that oxygen can't be negative. How do we figure this out? The iron has the possibility of 2 or 3. But oxygen, only 2. So, that green something. If the oxygen is 2 minus and we know we have 1 iron matched with it, it adds up to 0. What does that mean? The iron has to be. Question. Yeah. The arithmetic is easy. So I'm going to say this is iron 2. Oxygen. Okay. You must have the Roman numeral. If I say iron oxide without the Roman numeral, I don't know if it's the Fe2 or the Fe. Strategy for figuring out what the charge is. You always look at the anions charge. The anions don't tend to have the possibility of a 2 or a 3. backwards and see what's happening. Positive. This next one is a mess. A bunch of those. 4 different ions or elements involved. So the trick here is that the first thing is probably going to be same. With the exception of ammonium, NH4, that's the only time that compounds in my classroom, ionic compounds, will start with something that isn't. So like, here's ammonia, right? You want to watch for that. Otherwise, the first thing is a single atom. So I'm thinking, okay, this is Na and then HCO3. I'm going to write them down and we'll figure out the charge now. Na, HCO3. I've separated this. I know the first thing is metal count. I don't know what the charge of sodium is. What is the charge of sodium? It's on the left side, it's a metal. And I see a 1 that goes down. It's in the first column. We'll become familiar with a lot of it. Now, HCO3 is a collection. Polyatomic ion, you're going to look at the top. See, that minus 1. That's a bicarbonate. It's called, right? You ever heard of sodium bicarbonate outside of chemistry? Or outside of science? What is it called? Sodium bicarbonate. It's called sodium chloride. Move. Move for a reason. Not that. Oh, I got arm and pound. Cow brand baking soda, you ever hear of it? Oh, there's a cow brand. Oh gosh, you're arm and pound. And it says on it here, marqué de bicarbonate de soda. Okay, I'm looking at the French here. Baking soda, it says there, but sodium bicarbonate. Anyways, the ingredient is sodium bicarbonate. Baking soda. That's what that is. Anyway, but the proper name is not baking soda. Cow brand baking soda. Gosh, we have to do better at advertising. You guys don't know. You may look up cow brand baking soda. Use your phone. Now, this is, you guys use cow brand? No, actually, I use them now. I just use, I use whatever no name. I'm old too. You know, I'm a grandpa, so your grandma doesn't surprise me. Maybe they don't sell it. I don't know. I still talk about old places that don't exist too, like I'll say Taylor Field and stuff like that. Yeah. I'll say the Edgar Dome, the Center of the Arts, and you're going to oh, I'm a big dinosaur. Back to this though. Okay, I'm going to uncrisscross here. We have copper, and it's pretty obvious here copper is the lone. There must be a 2 minus, yes. Sure. Because that's a typo. I realize as I'm doing this. You're not. That's a typo. That's a mistake. So I'm going to just, you're right, CU2 SO4. I type these up and I copy and paste stuff like that. So anyways, thank you. Good one. Okay. CU2SO4. The first thing, I'm going to uncrisscross. Now, I say 2 groups of copper. I'm going to put the 2 charge on the negative, SO4. I know that's the single. Strategy. And SO4 is the left hole. Without the brackets, you then have to recognize whatever's left behind is the other thing. When I uncrisscross, I put the 2. It must be too negative. Try it. There's only one group of sulfate. So I'm going to put a +1. Now, I don't have to put the number 1. I just put a. Is there a copper 1? Yes, there is. There's copper 1 or copper 2, though. So even though I know the charge, I have to look it up to double check. I have to double check. Is this one of the ones where I have to list the number? So I do. Copper. Roman number 1. Sulfur. Okay. And then the sulfate stuff with the F. Sometimes old British kind of things, the CPA sulfate. That's okay. So, what you really have to check on is, do you need to, like sodium, when I look up that, there's just sodium with Na+, so you never put in the Roman numeral 1. You do have to reference your sheet, even though you knew it in chart. Okay. Now, practice-wise, I'm thinking, I'll handle this out. Do a few of these. I'm not going to do all of these. But I'm just going to do. And I'll tell you which one's one. Stop working well for you? Oh, I don't. Well, I'm handing these out. Here's what I'm going to ask you to do. So I think we understand what I want in each column. Ions and formula. I'll get you to do. Identify that you want to do the first. Yeah, these ones. First 3 of these. Then the next 3 on this section. I see there's some repeats from our examples, but that's not a big deal. Okay. So 3 and 3 from this page. Flip the page, and I don't think it'll be a surprise. And I want you to do 3 on this section. 3, 3. Yeah. That means I'm not going to give you this, and then we're going to check. I'll give the answers for everything on the video so that if you need extra practice, you have that available. Right? Okay, work away. Okay. I'm just going to briefly go over a few of these. I asked you to do the first 3. Okay. Recording, yes. Okay, so these are the formulas you should end up. Okay. That's the okay. So, hopefully you have these, right? If not, why you didn't? Usually it comes down to, did you have the right ions? I'm going to slowly scan through these. Don't try writing them all down. You know, you could just click to the video and just go to the end. I'll wait on this. You can pause the video if you're watching on video. Okay. I'll go to the next batch. These are the names you wanted for those first 3. If you need an extra practice, I'll slide a bit, let it be recorded on video, slide a bit more. There. Pages, is this okay, page 1? Okay. Page 2 tended to be a little more involved because I had polyatomic ions. And like you guys mentioned, chlorite isn't on the list, ClO2 ions. I don't use the ion chart when I make these out because I know most of the ions are all white. But anyways, so if there's ever something like that, I can see if you do it. If it's a test, I made a mistake, and I'll never get it on the board. Okay. So these are the first 3. then I'll record, or pause for a minute. Yes. I may have made a mistake, so call me up. Yeah.
Sorry. Chloride. Why is it chloride? The tin arbitrary is 1/4, and then the CiO1. Oh, never mind. Never mind.
Okay,
I
good,
was like looking at the wrong.
So if they aren't a match, crisscross, make sure they're in the lowest terms. When I say lowest terms, I'm talking like if you had 2 and 4. If you had a fraction of 2 out of 4, you'd say, well, that's 1 out of 2. Same with these. Okay. So I paused on this sheet a little bit here. The first 3, ammonium chloride, sodium iodide, sodium sulfate. If needed, the rest are. Okay. I'll let this record for another. I wanted to just get one thing started. Continue it tomorrow, and it's balancing equations. We're going fast because this is all review stuff you've seen before. Okay? Now, I'm starting with the first 2 examples, and I'm doing it at a very basic level. Now, I'm going to use diagrams. That's why you have these bubbles on the side. So, the first thing is we've got to know what oxygen is, and I've been harping about this. If I say oxygen, you say formula O2, not just O. So we're going to write these in here. O2 plus hydrogen. It's one of the 7 that comes in group 2. Water, H2O. I know. Pause. The first thing you need to do is come up with it. Now, I'm going to say, once you do that, you can drop your pen for a second. I want you to pay attention because I really want you to understand what it means. Okay. So, oxygen is O2. So this really represents 2 atoms of oxygen. Hydrogen, H2. H2O, that looks like Mickey Mouse. Oh, okay, H2O. When I count, and I literally count the atoms, 1, 2, only 1. I have a mismatch of oxygen. I have enough hydrogen. But I obviously need more oxygen on the right-hand side. The products. Reactants, like starting things, react to form the products that should produce work. I've got an arrow that I didn't put in here. Okay, so you have chemical equation, but don't worry about the diagram or watch. This means that I need more oxygen. So they only come in groups of H2O on the right hand side. So I've got to grab it. Another H2O. At this point, I have the oxygens balanced, right? I have 2 oxygens on the right, 2 on the left. You know what that represents, right? This is a review. And now it's screwed up the hydrogens. They only come as groups of H2. So now I think I have it balanced, right? Now, you guys are beyond pictures. I think you might have used them maybe or 9 or 10, maybe. I didn't. So, how do we do this without pictures? And we'll reflect on that out. Well, I take a look. Now, I have the answer underneath of that 1, 2, 2. But I think O2. Thinking O2, I need 2 rows. So I need to double that up. Put a 2 here, right? Now that's screwed up the hydrogen. So now I think 2 times H2 from the water is 4. So I need 2 times H2 on the left. This totally represents what's in the diagram below. That's the same number of particles in each. Mass is conserved. Now, next one. So make sure you got your balance. That's what you need, not the diet. The next one, I told you that it's something, we call them organic molecules when they're C's and H's. Carbon. Methane, I have to tell you, see, move that over to the balance. Oxygen, we need that. We'll leave space to balance phosphorus. Carbon dioxide, one carbon, because it never starts with mono. Di-O2 plus water. Now, I'll quickly do a diagram and we'll see. CH4. O2. Arrow. CO2. See how this works. Okay. I look at my CH4 and I say carbon. Yeah, there's enough carbons in everything on left and right side, right? But nothing else matches. The hydrogens are out, the oxygens are out. Why don't we go with the hydrogens? Just because I'm thinking CH4. CH4, well, the only way to get hydrogens on the right is to come as groups of H2O, right? So I'm thinking need another set of water. Put that there. Now I've got 4 hydrogens. Good. Yep, side right. So you know what this represents. Now I need to double check on the oxygen. We've got 2 on the left, 4 on the right. Hey, this works because they're even numbers. So I'm going to go with another set. Another set of oxygen. I've got it balanced. The trick is to figure this out without doing a diagram. So I don't need to put a number 1 in for CH4. I'm just going to leave it. So that's a 2. 1 group CO2, 2 groups of water. Sometimes people need that visual though to just get in their head what this represents. I don't recommend using visuals. It'll take you way too long. You guys are, you've done this. Try these problems. This is what I'm leaving. Okay? This is your homework. You've got 3 minutes now. Keep working on it. Don't tuck it away. We're working on it. Remember, someone's paying your tax dollars to get to school. So don't rip them off. Okay.